Welcome to our channel. In today's video, we will be looking at how to integrate a user diagnostic fault checker in your TAA portal program. This will help in detecting faulty modules or devices in your network configuration and displaying the faulty devices in the HMI for easy diagnostics. Basically, all SIMatic products have integrated diagnostic functions that allow you to detect and clear faults. The components automatically report a fault during operation and provide additional detailed information. So this video will help you configure your TIA software with a user program in order to detect faults and display them in the HMI. We will be making use of the user program provided by Siemens in this webpage. The link to this webpage can be found in the description below. We will trigger a fault on the devices using the PLC SIM v19 and then observe the fault in the user program and use the HMI to display the diagnostic fault. If you have not seen our video on simulating with TIA v19, kindly check the video in the description below. Siemens provides us a project containing the diagnostic configuration, of which I will show the program blocks contained in the project. I will proceed to download the user program. I will be making use of the Wincc Professional, which is the second option. Here is the downloaded zip file. I will proceed to open the project in my TIA v19. This means I will be upgrading the project from v15.1 to v19. Upon opening the project, I will do a quick overview of the blocks contained in the program and then proceed to run the simulation. Do kindly stay with me here. Here we have the user diagnostic program blocks that helps to read the diagnostic state of the I/O devices. Also here we have the main block. In the user diag, we have the call of the diagnostic, also the get IP address block, and the diagnostic HMI block. And in the diagnostic block, we have the PLC check block, which receives the CPU system constant as an input. Also, we have the I/O system check block, which receives the Profinet system constant address as an input, representing the I/O system 1, and the network below receives the Profibus system constant as the input, representing the I/O system 2. As we continue with the video, we get to understand better. Basically, these are like the major blocks that makes up this user program that helps detect diagnostic fault. Here is the device configuration. As we see, we have two I/O system connections, the Profinet and the Profibus. Back to the user diagnostic block, we see the connection to the Profinet I/O system, and here we see the connection to the Profibus I/O system. Here we have the data block where we can monitor the faults across the I/O system network. That is the Profinet and the Profibus system interface with a max of 128 device as defined in the user data type. Here we have the I/O system 1 for the Profinet interface and the I/O system 2 for the Profibus interface. And we see the number of devices that can be read is 128. These I/O system data array is connected to the I/O system check function block via the I/O system data tag. Let's see the user-defined constant in the PLC tags and the user types declared in the project. In the user-defined constant, we can define certain variables to hold constant values we want to use in the code. For example, the maximum number of devices per I/O system declared in the array, which is 128. If we would like to increase the number of devices or reduce, we can change this value here. Also, the number of slots is defined to have a constant value of 31 in this case. In the user-defined data type, we see the structure that makes up the PLC data, the I/O system data, also the devices. Now, I will proceed to run the simulation on v19, after which I will show how to view the diagnostic state behavior in the HMI. So, if you have not seen the video on simulating with v19 PLC Sim, do kindly find the link in the description to see how to simulate a diagnostic error using PLC Sim v19. So, here we have the instance generated, and I can download to the PLC instance. I will run the PLC and go online to observe the state of the DEBC in the diagnostic data block and also observe the state in the device and network configuration view. As we see there are no errors generated, I will now generate a plug-out fault in ET200 SP1. Here, we select the event and the appropriate system constant for that event. I will check the system constant in the device property window. The cause will be an I/O module removal. As we see a fault is generated, here in the PLC data tag, we find the error variable being true. Also, the I/O system 1 indicates an error. And we can see that this is associated to the first device, as we see here. The second device shows no fault. We plug back in the module, and we see the data block indicates that the fault is gone. Let's do a channel wire break error on the second slot of I/O device 1. Here, we select the diagnostic interrupt type. Let's get the system constant of the card. Once again, we can trace the fault in the diagnostic data block. As we see here, the second slot is affected, and we can see this in the data block. You can go further to make use of this diagnostic result obtained in this block in other part of the program as you wish. Now let's proceed to show this diagnostic fault in the Wincc Professional HMI. Here in the HMI, we have the screens that helps to visualize the device diagnostic status. Here is the screen topic 0020 showing the I/O devices. Here is the pop-up overview module screen that shows the cards in the slots. And here is the HMI tag table, which has the tags linked to the PLC tags. Let's run a simulation of the HMI to see the behavior. Now we have Wincc being launched, and here is the HMI. Here it seems the HMI is not properly connected to the PLC. I should be seeing the list of IOs below, but that's not the case. I will try to trigger a fault to see if it is read in the HMI. Here the fault is seen in the device and network config, but not in the HMI. This confirms that the HMI is not connected to the PLC. Let's stop the runtime. We can resolve this connection issue by checking the connection settings of the HMI. I will change the access point to S7. Now let's run the HMI once again. Here, we have the HMI retrieving the I/O devices in I/O System 1, showing that it is well connected to the PLC, and we see that device 1 also has a fault, which is indicated in yellow. As we see in the legend, yellow means faulty state. We can go further to check the device to see the corresponding slot, slot 0, which indicates that the I/O island itself has generated the fault. And below, we can find the name of the device. Back to PLC Sim, we will fix the error and observe the state in the HMI. As we see here, we have the I/O island back, with a yellow borderline indicating that it was previously in an error state. Here in I/O System 2, we have a single device which is connected to the Profibus. By using the filter button, we can filter the I/O devices. I will play around with I/O System 1 devices. In PLC Sim, I will trigger a fault on device 2 and also on slot 2 of device 1. Kindly like, share, and subscribe to our channel for more updates like this. We will now be transferring the program into our project using the project library functionality. I will now end the runtime of the HMI and proceed to transfer this user diagnostic program into another project. Here is the project I want to configure to have the Siemens User Diagnostic Fault Checker program. We had created this project from scratch in the hardware configuration video. We will trigger a fault on the devices using the PLC SIM v19 and then observe the fault in the user program and use the HMI to display the diagnostic fault. To start with, here we have the device and network config project. As we see here, we have a single I/O system, which is the Profinet interface, connecting to a different set of I/O devices. In the description below, you will find a link to the video on how to carry out this ring connection. Back to the user diagnostic project we had downloaded. I will be creating a new global library called Diagnostic Program, and then I will move the user diag folder, which contains the program block, into it. I will also be moving the PLC tags and the PLC data type, which are used in the program blocks. Finally, I will be moving the entire HMI device station into the library. Having done that, I will save the library and close it. Back to the device and network project, I will be opening the library. Ensure the open as read only is unchecked. Now that the library is opened, I can access the master copies. First, I will copy the HMI PC station into this project. As we see, it is now added into the project. Next, I will connect the PC station to the PLC network, which will be done in the network view. Now I will also copy the program blocks into the project. In the main OB, we will call the user diagnostic main block into it. I will also need to ensure that the clock memory bit, which can be found in the PLC property, is enabled. Let's examine the program block and data block. As we see, the PLC data types and the PLC tags are also added. We would need to compile to get the blocks to read the PLC data types. Here we have an error due to the Profibus interface we added here, although not used in the network configuration. Since the Profibus interface does not exist, we can take out the tag. Here in the network view, we see there is only the Profinet interface. We can find the list of hardware IDs in the PLC tag, System Constants tab. Here we can find the hardware device ID values. Now we can proceed to run the simulation and visualize the hardware diagnostic error in the HMI. Here is the new instance created for the project. We proceed to download the project into the instance and go online. Once again, we will trigger the diagnostic event and monitor the event in the diagnostic data block. Here we select the second instance and the pull or plug event. I will then insert the concerned hardware address, which is 278, representing the Profinet interface for I/O device 2. Here we have a plug-out fault generated on I/O device 2. In the diagnostic data block, we see the error tag value true, and scrolling to find the device which triggered the fault, we see I/O device 1 has no fault. Drive 1 also has no fault, but the error is due to I/O device 2, as we see in the data block. Let's proceed to run the HMI. Here we see no connection, which is unexpected. Let's figure out the cause. Here we have the PLC running fine. The connection also looks fine. Let's check the IP address of the PC station. The PLC and station are in same subnet. Let's check the protection and security. Here we find the PLC set to no access. This means the HMI will not be able to retrieve data from the PLC. To resolve this, I will be changing the access level to full access. I will download the program again and go online. Now we have the HMI data retrieving the I/O devices in I/O System 1, which is the Profinet interface. Here we have I/O device 1, and we can see that the HMI represents the device hardware configuration. As we proceed to trigger a diagnostic event error, we will see the behavior of the devices on the HMI. Let's trigger a pull and plug event on I/O device 1 and also a channel short circuit error on the safety card of I/O device 1. We will select the event and the concerned address to be triggered, and we will trigger the error. Once again, we see in the HMI that the I/O device 1 is faulty, indicated in yellow. In addition, I will trigger a short circuit fault on slot 1 I/O card. Here we see that the card is also indicated to be in fault state. Finally, we will restore the state of the devices. In this video, you have seen how we can add the diagnostic user program into the TIA project and view the state of the I/O devices in your network configuration. Kindly like, share, and subscribe to our channel for more updates like this. See you in the next video, and good success.